Do you remember that scene from Iron Man where Tony Stark walks into his own home and his AI assistant Jarvis starts building these schematics for his suit, starts analyzing the threats, and starts controlling things in his own house? When watching this, I thought it was the coolest thing in the world. I always dreamed of having my own AI assistant that helped me with my homework, that helped me with other things in my life. It's just a way to get things done just a lot faster. Now, this day and age, we have things like ChatGPT and Gemini, which help a lot with like homework and creating pictures, things like that. But I'm here to introduce something that takes another step closer to that dream and making it a reality. This is Google's Agent Development Kit, or ADK for short. With this tool, you can create your own custom LLMs to make them do whatever you want them to do. The way it works is that you have these specified agents that have very specific jobs that you assign to them, and you basically let them work together in order to solve a problem of your own. Now, in order to show this, I'm going to make a weather bot, as done by the tutorial on Google Colab, and we'll get a feel for how to actually make your own custom LLMs. The purpose of this weather bot is mainly just to get the weather of a specific city. Now, even though this may seem really simple, it's a really great starting point to understand how to use Google's ADK and all of its features that it provides. To begin, first you need to install your frameworks. And to do this, I'm going to use the Google Colab tutorial to get a better picture of what we're doing. So as you can see right here, the first step is to do a pip install with the Google ADK framework and the LiteLLM framework. That's going to be used later. Next, you want to install your libraries. Now, these are the libraries that we're going to use throughout the tutorial here and there. After that, the most important part of this is that you need the API keys. These are going to help you communicate with ChatGPT, with Gemini, with Claude, depending on what you want, and it allows the program to actually use and utilize the functions of these LLMs. To get your API keys, you go to the website as stated in those comments, you make your key, you name it, and then you basically copy and paste that key into these functions down here. And don't mind these print statements, these are just to check to make sure your API key actually is functional. So before we even make our agent, we need to make a get weather tool. Basically, as the name implies, this is going to be a tool that the agent uses in order to execute its primary function. As you can see here, there are three aspects of this function. There's the docstring, there's the database, which stores all the mock weathers, and then there's the part where it parses the prompt and then gives you an answer. So there are preset texts for preset locations. So when the function parses the prompt, it looks for a specific location, and if that location exists within the database, instead of the LLM giving its own response, it'll actually take the response from the database and give you that instead. Now, the docstring is arguably the most important part of this function. Though for coders, it just seems like a comment that doesn't do anything, this docstring actually helps the LLM to understand what this tool actually does. Finally, we can start making the agent. So to make an agent class, you need the name, which is just a string that you're going to call the agent. You need the model it's going to use, which would be either ChatGPT, Gemini, whatever API key you chose to use. Then you need a description. The description is basically just an explanation of what the agent does. After that, you're going to need the instruction, which basically tells the LLM how it should be acting. It asks for what prompts it should be receiving, and then how it should respond to those prompts, what it should do with an error, things like that. And then you need the tools, which is the get weather tool that we made before. This is what the agent will use when answering questions. Now that we've finished the agent, there are two more things that we need. We need a session service, which stores the conversation history, and then we need the runner, which gets the input of the user, gives it to the LLM, and then takes the output of the LLM and gives it back to us. When running APIs with LLMs, there is one thing to note. When you're doing input and output from when you're having a conversation with the LLM, there's a lot of delay, especially with the IO bound operations. So one thing that the runner does is that it runs asynchronously, which to sum up, it basically makes those operations a lot more efficient. To do this, we're going to make a helper function called async, and this should help accomplish what we want. With that, we finally have our first chatbot. Now you can ask it about the weather in London, in New York, or Tokyo, and it'll give you the information about that. And if you ask about a city that it doesn't have the information about, it'll just give you an error. Granted, it doesn't have the bells and whistles just yet, but we'll get to that. Now, the next step talks about using a multimodal structure when creating your agents, which basically means you can use ChatGPT as one of your agents, you can use Gemini as a different agent, whatever you want. The reason for this is to play into the advantages that each LLM brings to the table. So if you want a large context window when talking to your weather agent, you probably use Gemini. If you want speed and quick responses, you would probably use ChatGPT Mini, things like that. I'm going to skip over this for now, but if you want to know more about this, I suggest going to the tutorial and learning about it there, or you can check out our blog post that goes way more in depth with it. Let's move on. So now we have an agent that can tell you the weather. However, there's still other aspects that I want this agent to do. Like I want it to say hi when I first log in, and I want to say goodbye when I log out. So we could just make the same agent do the same things, but that gets a little fuzzy, especially when it has a lot of responsibility to do. What we should do instead is delegate different tasks to different agents. So instead of making one agent do everything, we're going to make two more agents. One that's solely just for greeting the user, and one that's just solely for saying goodbye. Just like we did before, we're going to need the tools first. So we're going to have the say hello tool and the say goodbye tool. Then with the agents, we'll put the say hello tool and the say hello agent, the say goodbye tool and the say goodbye agent. We also will have the description, the instruction, the name, and the models as well. Now we can finally combine them all together. So when creating an agent that uses other agents, we basically create it in the same way. First, we create the root agent, which is going to be our weather getting agent. So it'll have the tool of get weather, but we're going to have another category that adds the different agents that it will also utilize. Important thing to note when writing the instruction for this root agent is that you should also specify the fact that it will use other agents for different tasks. We can test this out, seeing that the agent now can say hello, goodbye in the ways that we want to, and still has the functionality of the get weather agent. All right, at this point, our agent's pretty much done. We got a pretty good weather agent that gets the weather and delegates tasks as needed. Now let's add some little more tweaks to it to make it even better. For one, I think something that we could definitely do is make it so it actually stores memory. Because as of right now, every time you make a new session, the memory just resets. So it doesn't have any saved memory from previous sessions. So let's start adding that feature as well. To do this, we're going to use the session state as provided by ADK. This is basically the long-term memory of the agent, and this is programmable memory, meaning you can read to it and write to it with the agent or manually through the code. To start off, we're going to use the in-memory session service object. And this object is going to help us create a session state and also get information from our session state. To create a session, you're going to use this function right here. This function takes 3 strings and then a dictionary. The 3 strings are going to be the app name, the user ID, and the session ID. And these can be whatever you want. Now the state, this is going to be a dictionary. And this dictionary is going to contain the information that you want to be stored with the agent. In order to utilize the session state, we're going to have to use the tool context object. This is basically the bridge that allows your tools that we created for our agents to communicate with the session state. Let's put it all together now. Now, of course, we start with making the tool. Again, most of the code stays basically the same, except for right here and here. This piece of code basically gets the session state information that we want. And then this code right here uses that information and dictates what kind of response the LLM should give to you. Now, if you notice, the mock weather database did change a little bit. The only reason this is how it is now is just so the information is more standardized. Now, just like before, we're going to create our greeting agent, we're going to create our farewell agent, and then we're going to create our root agent, which contains both of those agents. But this time, our tool is going to be the get weather stateful tool, which uses the stateful session. And we're also going to use an output key, which basically auto-saves the agent's final weather response to the session state. One more thing to note is that the runner object for the session service parameter, it will use the session service stateful, which if you remember, we defined it as the in-memory session service object. Now, the final thing that ADK offers are guardrails. These are specific questions that you specify yourself that you don't want your LLM to be answering. Now, there's 2 types of guardrails that ADK offers. There's before model callbacks, and then there are before to callbacks. Now, the before model callback works basically immediately. As soon as you say a phrase or a keyword that you specify as a restriction, it stops the LLM from running entirely. The before tool callback, on the other hand, works after the LLM has accepted the request. So the before tool callback stops the functioning as soon as the LLM chooses which tool it wants to use. So the tutorial has a lot of code when implementing the guardrail feature, and instead of going line by line explaining what each part does, I'll just sum it up real quick. Basically, this part of the code gets the last user message that was asked by the LLM. And then this part of the code basically parses through the message and tries to find the block word, which is defined right here. Now, if it finds the block word, it prints out this piece of text right here. Now, to implement it into the root agent, we do the same thing before and add this new parameter called before model callback, and that's where we add the block keyword guardrail that we created before. The difference between the before tool callback is that it checks for a target tool name and a blocked word. So it checks whether the LLM calls a certain tool and blocks a certain phrase or word that the tool is going to use. As you can see in this case, we are blocking the get weather stateful tool when Paris is called. So anytime we ask about Paris to the get weather stateful tool, we're going to be given this response, policy restriction. To end it off, we finally put the before tool callback into the root agent. So we create the root agent the same way as always. We add the tools, we add the sub agents, we add the output key, we add the before model callback, and now we add the before tool callback. And just like that, our agent is finally complete. So we did it. We made a whole weatherbot agent that gets the weather, that has different agents for saying hello and goodbye, and it has guardrails and a whole memory system to go along with it. Now you're on your way to create your own custom LLMs. Let us know what things you create using Google's ADK, because we would really love to hear about it. But besides that, thank you so much for watching. We would love to hear other things you think we should review.